Now as we're progressing through the exam, the problems are getting a little more difficult. Now we've got to be able to look at this problem right here and figure out what solution are we going to use. Is this integration by parts? Is it going to be simply recognizing the antiderivative, U substitution, trig substitution, trig? What's going on? Well, the first thing I would do is I always look and see, okay, here's a tricky function. It's one of the trickiest functions in the whole thing, a log. But look at this, log of z, and over here we've got 1 over z. So here is a function, and somehow it's derivative. Okay? So I'm saying, hey, this is probably a u substitution. Now what am I going to make u equal to? Well, you see how this term here is raised to a power. I would like to make this whole thing equal to u. And then du, can you see what du would be? It just, well, there's a minus sign here, so we've got to put a minus 1 over z dz. Alright, now, so let's write out our new substituted in form, and we get 1 over u squared du. But of course, this can be rewritten as, oh, wait a second. We didn't consider that minus sign. There's no minus in this term, so we got to put a minus out front. And this should really be written as minus 2 du. So our power rule will be easier to apply. Now we go ahead and integrate, and we get u to the minus 1. There's a minus here, and of course there was a minus out front to start with. So now we get just u to the minus 1. Now we go back to our table of u and substitute in, and so we get this is equal to 1 over the quantity 6 minus log of z plus a constant. And it could be written like that. I suppose you could alternatively, if you prefer, write it as 6 minus log of z to the minus 1 plus c. Although I suspect this would be a more conventional way to write it. Although I like to work with this form here, where the exponents are written out.